All right, good afternoon. Happy Wednesday. I know this is one of those long days where we're not in all of our classes. Just a couple of announcements. And I'm giving the announcements at the beginning because I'm giving important announcements. Everyone who's late aren't going to get them. So at the beginning, I was putting the announcements in the middle. Now I'm putting them at the beginning. So everyone who's late, they don't get the announcements. Make sure you're responsible for turning your work in on time. I'm not accepting late work. And so you need to either write them down on a calendar or mark them somewhere so you know when the assignments are due. Also, I had a few students asking me if they could retake the last exam, and the answer is no. And the reason why is if I allow somebody to take it over again, I have to allow 150 people to take it over again because it's only fair. You know, if a person has an 80%, that's a great grade, but they're going to want to take it over. And so I just feel like if I give one person the opportunity to do something, I need to give all my students the opportunity to do that. And I'm not willing to do that. So in another vein, when you're in college, they're not going to let you retake tests. I mean, that's not going to be an option. You know, if you don't prepare for a midterm and you fail it, you'll spend another $900 to take the class over again. So there's no such thing as retakes in college. So I'm trying to just give you an idea about what real life is, and you have to be prepared for a test. Now, the good news is that I am throwing out the lowest test grade at the end of the semester. So you get the lowest test grade thrown out. I've noticed too that some people are never turning in an assignment late, never turning in a test late, never having a problem with their scratch paper. And I've noticed that there's a few people that are always having problems. So just know that I have a lot of students that are having no issues whatsoever. And so I don't know if I can believe what's going on or not. So make sure you turn things in on time. There was a person who contacted me immediately about not being able to upload her scratch paper like at 9:05. So we made another arrangement, but I want things in on time. So it's not going to be easy for me to shift on what I'm saying. I'm happy to meet with, I'm not talking about the program making mistakes either. You know, if the program makes mistakes with the graphing, of course, I'm going to raise your grade. I'm not talking about things like that. I'm talking about things that you're not doing on your end. That's what I'm talking about. I'm not talking about the not working right or something like that. But always, you know, my door's open. If you want to talk about something, we could absolutely talk about it. But I'm going to be pretty strict because we've been doing this since August. I've given you guys a lot of breaks. So I'm being kind of strict about things now. The other day, I talked about the exponential growth functions, but I didn't finish the lesson. So I am going to do the lesson today. And I also signed this practice. So I want to take questions on this first. If you have any, I'm going to finish my lesson. There is no answer key to this, and I'm not going to make one. So it just so happens I don't have one, and I don't have time to make one. You can check with your classmates, you know, to see what they got. If they got, you know, something similar, you could cross-check your work with your classmates. Okay, and I you to do that. Anyone want me to work? One thing I was going to say about the point I was making about these graphs is you don't necessarily have to find the points that are on these graphs. You just have to make sure that the points that you find are on the graph. So I think I explained that yesterday. So you're not necessarily finding these points that they're giving. You just have to make sure the points fall on the graph. Okay, anybody want to ask me a question about any of these, or anybody want me to work a problem?
There were certain problems that I couldn't answer because I was kind of confused because some of the functions had e's in them and I didn't know what that meant. For example, 10 and 14, those I couldn't really go through.
That's because I don't teach about the E number until the third lesson. So here's what we're going to do with that. We're going to skip some of these. I'm going to tell you which one to worry about, but we're going to come back to them when I do teach. E is a number like pi. You know, pi is 3.14. And I didn't notice that that was in here. So it's 2.7. And it's used in banking. It is on the calculator. So it would be, E would represent exponential growth, but I haven't yet. So let's take a look at these. Number 10, you can just sit out for now. Which other ones have the E number? Number 14, you could forget about for now. Number 18, you could forget about for now. Number 19, you could forget about for now. And when I teach the E number, if you want extra practice, I'll either bring this up or you can remember that there's problems on here that you can practice with the E number. It is a number though. Sorry about that. So I did not notice those, but yeah, I haven't talked about the E number yet. So the way it's going to work, 13.1 is exponential growth, 13.2 is exponential decay, 13.3 is the E number. So sorry.
So right now, since we haven't learned about it, is it okay if we still like turn in our percentage as 100 even though we're excluding these problems? Okay.
Yeah. You're gonna omit those problems. You're gonna take those problems out and turn in your percentage based on all the other problems except for those. So take those problems out. Okay, anybody want me to work a problem that's not one of those problems? No? All right, well, today we're going to do some modeling problems. You're going to need your calculator, and we're going to use the intersect feature. And if you remember the intersect feature, remember it was the graphical approach where we put in something for y sub 1, and we put in something for y sub 2 in the calculator. We use the intersect feature to solve the problem. That's what we're doing today. So if you can grab your calculator, I'm going to grab a tissue. All right. And can you open up your books to 641? So we've done two objectives. So we've graphed exponential growth functions using transformations, also written equations given the graph of an exponential function. And now what we're going to do is look at modeling. Anybody have a question about anything before I get started? All right, so there is an equation for an exponential growth function. It looks like this: f of t is equal to a times 1 plus r to the t. And this is where a is greater than 0, and r is a constant percent of increase. So r is a percent, And the key word here is increase. Increase and growth go together. For each unit I can't play right now. Lay down. Okay, where A is greater than 0 and R is it's a percent of increase for each unit of increase in time. All right, so let's label these real quick. So this A, or this one, is called the growth factor. And of course, this is time. And this is going to be a rate, which is a percent. And A is usually an amount that you put in to it. So we're going to look at a guitar example here on page 641. And by the way, you might see this on the final, and you might see this on the CASP test, the science test for 11th graders. I would know this. All right, Tony purchased, so they want us to find a function that corresponds with the given situation and then use the graph to make a prediction. Now, this is not a prediction like from the Psychic Friends Network. This, excuse me, this is a mathematical prediction. So successful businesses do this all the time. They predict the future by looking at what's happened in the past. So it's a mathematical prediction. So it says, excuse me, Tony purchased a in 2000 for $12,000, expensive. Experts estimate that its value will increase, that's a key word for this formula, by 14% per year. It says use a graph, and we're going to use a calculator to find the number of years it will take for the value of the car to be $60,000. So we want to write this down, f of t. So go A1 is r to the t. And we're going to set this up. Then we're going to use a calculator. But just a reminder that our variable, they're asking time. So our variable is going to be x, which is t in this problem. So in the problem, our A is going to be the $12,000. Our R rate is always a percent, you guys. So they're saying that the percent is 14%. And remember that percent means per 100. So that would be 0.14. So what you have over here is 0.14 to the T. And they want to know how long is it going to take to get to 60,000. So 60,000 is our answer. It's our outcome. And 60,000 is going to go in for Y. Now, I'm going to simplify this right now. Remember, when you add decimals, you line up the decimals. So this is really 1.0 plus 0.14 is 1.14 to the T power. So what we're going to do is, in our equation editor, we're going to put 12,000 times 1.14 caret x, which is t. Into y sub 2, we're going to have a string through 60,000. Now, here's the deal. The hardest thing about this is getting the window to capture the intersection, because the answer is going to be something 60,000 And our x is going to be the time, right? Because x is the first, it's xy, and x is the time in this problem. So after you put this in the equation editor, you have to mess with the window. Pay attention. If this is going through 60,000, you're going to have to go from 0 to 10,000. Sorry, you're going to have to go from 0 to 100,000, counting by 10,000 to capture the line. Do you follow what I'm saying? Okay, so let's everybody put this in the equation editor. So go to y equals and put in 12,000, print 1.14 caret x, and under y sub 2, put 60,000. Now don't hit graph yet. Go to the window. And under the window, now I'm not talking about x min, go to y min and put 0. And go to y max and put 100,000. That's 1 with 5 zeros. And we're going to count by 10,000. So that's a 1 with 4 zeros. So when we hit graph, we should get the line that's 60,000.
Wait, where did we put the 10,000?
How you're going to count. You're going to count by 20,000, 30,000, 40,000, 50,000.
I thought you meant to put 10,000 somewhere.
Yeah. So I'll say it again. Under y min, you're putting 0. Under y max, you're putting 1,000. Under y scale, you're going to count by 10,000. And we hit graph, you should be capturing the line. Now, as far as this other graph goes, you have to mess with the x coordinates to try to capture the point of intersection. So let me know when you capture the point of intersection, let me know what your x is defined as. All right, so I got it. So I'll tell you what I got. X min, I put a 0, and I put X max as 20. My X scale, I'm counting by 5s. So I put a 5. My Y min is 0. My Y max is 100,000. And I'm counting by 10,000. And if you hit graph, you're going to get that. So you should expect that, right? This is a line, and this should be some type of exponential function because the variable is an exponent.
Wait, I didn't get that. I got 2 straight lines.
Put it in the equation editor, right? Did you put caret t? That's a power. That's not times t, that's a power t.
I put that in, and I think I got the same thing. Just 2 straight lines.
There's no way. This is there's no way. This is not put in right. It's got to be this caret t, or I'm sorry, this caret x.
Oh, I put, okay. You put X in.
So remember the variable is always x.
Yeah, it changed because I put a T in. No, it's not straight.
So now you go to second trace and you pick the intersect feature and you see the spider. You're going to hit enter. He's going to jump to the other graph and you're going to hit enter. You're going to ask the calculator to guess, and what do you get?
Like 12.28.
So guess what that means? That means that the guitar will be worth $60,000 in approximately 12.3 years, or about 12 years. So the guitar will be worth $60,000 in about, and depending what they're wanting you to write, you could put 12.3 years or about 12 years after its purchase. All right, the next problem we do, it's going to be a little bit different, but we're going to use the calculator once again. Any questions about this? So the hardest thing is trying to set up your window to capture the point of intersection. Okay, anybody want this repeated, what my window looked like or anything?
Can you repeat your window, please?
Okay, can you write it down, please? Write it down. X min is 0. X max is 20. The X scale is 5. We're counting by 5s. Y min is 0. Y max 100,000. That's a 1 with 5 zeros. Y scale is 10,000. That's a 1 with 4 zeros. So in other words, on the y-axis, I'm counting by 10,000s. Not counting by 1, 2, 3 anymore. We're counting by 10,000s now. 0, 10,000, 20,000, 30,000, 40,000, 50,000, 60,000, all the way up to 100,000. That's how we're counting. Were you able to get it?
Yeah, I got it. Thank you.
Anybody else? Anybody else having trouble getting this? Okay, the next problem is a little different, but we are using the same function. Our t is still x. So I've said this before, but I'm going to say it again. You never put in variables other than x. The calculator understands x. So if your variable is z, you're putting in an x. If your variable is t, you're putting in an x. If your variable is y, you're putting in an x. All right. So in this problem, let me read it. It says at the same time that the $12,000 guitar, he also considered buying another rare guitar for $50,000. Experts estimated that this guitar would increase in value by 9% per year. Determine after how many years the two guitars will be worth the same amount. So this is done a little bit differently. So watch this. So we have F of T is equal to 15,000 this time. Our R now is 9%, which is 0.09. So we're putting 1 plus 0.09 to the T power, which is X. And we're writing this as 15,000, line up the decimals, 1.09 to the T power. Now, in this problem, we're not putting anything in for that. We're actually equating the two problems. Because notice what it says. It says, determine after how many years the two guitars will be worth the same amount. Well, same means equal. So what we have to do is we have to equate them. And
Wait.
the other one was what, 12,000?
What happens to the T in the 1T.09?
The T?
Yeah.
Right there?
Oh no, like I mean like in the parentheses next to the 0.09 in the first one, where F of T equals 15,000 and in the parentheses 1T.09. Where does that T go?
1T. That's plus.
Oh, that's plus. My bad. I thought that was T this whole time.
Yeah, plus. So that's plus. So that's why I'm adding 1.0 plus 0.09 is 1.09. And now, did you see how I equated the two problems? So under y sub 1, you're going to put the 1 problem. Under y sub 2, we're going to put the other problem. And our answer is going to be, the x is going to be the time, and the y in this problem is going to be the amount when they're the same. So we want to put these in the calculator, and once again, we have to mess with the window. And this one's even harder because we don't have a horizontal line. In the other problem, we had 60,000. But in this one, we're just like kind of left in the dark to try to figure out where the point of intersection is. So let's put these in. So this one's already in my calculator. And this would be 15,000, parenthesis, 1.09, parenthesis, raise it to the x power, which is t. And I don't even know where to start. So I'm just going to hit graph and see what I come up with. Okay, I'm getting this first function. I just have to find the other one. So I'm going to actually I got both of them. So I'm going to kind of mess with this, or I could just leave it and do the point of intersection. Did you guys get this? Can you guys see this?
Yeah, I got that.
Yes.
Okay, so let's just do the point. Let's do intersect right now. So go to second trace. Go to 5 for intersect. See him on the one graph, hit enter. He's going to jump to the other graph, then hit enter, and then hit enter, and tell me what you get.
For X, I got 4.9, and for Y, I got
1 or 4.975.
yeah, 4.975.
Okay, and what'd you get for Y?
23,030.
$23,030.22.
Yeah.
That's right. So watch how I'm going to write the answer. After about, and you could, depending on what they want you to do, you could say 4.98 years or about 5 years. I'm just going to write after about 4.98 years, the value of both guitars will be about $23,030.22. So this is how we can use the calculator to do a complicated problem with a bunch of big numbers. So this one here, we set the function equal to 60,000 because that was our goal. Over here, we want to equate the two because they wanted to know how long will it take for them to have an equal amount. And like I said, the hardest thing will be messing with the window. All right, anybody have any questions about this? That's it for this. Okay, I want to show you something else. It's on the, I haven't posted it yet. It's on the practice AB problems 1 and 2. So I think that practice sheet is due, I think it's what, tomorrow night, Thursday night? Now, these two problems I'm going to do, you guys, I personally think they're the hardest problems to teach, and they're the hardest ones to understand for me. So I'm going to try to explain this, but it's kind of like there's some guessing involved. So it's kind of like guess and check. All right. Now this is on the practice AB. This is problem number 1.
You want to write down in the notes?
I would write it down. I would write everything down that I write. So what they do is they give you this table and they ask you to write an equation. Well, we don't know if this is a quadratic, a cubic, a cubed, absolute value. We don't know if it's a logarithm. We don't know if it's exponential growth. We don't know if it's a line. We know nothing. So my recommendation is graph it and try to see what it is, because I don't know how we're going to write an equation if we don't know what it is. So 0 up 6, right 1 up 18, right 2 up 53, right 3 up 162. Does that seem like a line to you? Or does that seem like it's going up exponentially?
Exponentially.
Yeah. So I'm also looking, so I think it's an function. Means that the variable is going to be the exponent. And then I'm looking at this and it's like, when was the last time we saw tables? Arithmetic sequence, geometric sequence. So I'm looking at this thing like, that looks geometric to me. Let's just see. 18 divided by 6, 54 divided by 18, 3, and if you do the other one, it is geometric. Well, watch this. Wasn't our geometric sequence a times r to the n with a starting position of 0? And is that exponential? So let's just see. F of n, the first term is 6. The common ratio is 3. And let's keep our fingers crossed that this works. So here we go. Put in a 0. Is 6 times 1 6? Yes, it worked. That doesn't guarantee the other ones work. So now we put 6 times 3 to the 1. Is 6 times 3 or 18? That worked. Still doesn't guarantee we're right. It's got to do a few more. 6 times 3 third. 6 times 54. Now I have a high level of confidence that this is the answer. And if you do the other one, this is what they're asking for. Go get it. I don't know if you guys can see what's going on, but my cat keeps dropping toys at my feet and he wants me to, he's playing catch. So he's driving me crazy right now. Anybody want a cat? You can come get him because he's being really needy right now. So look at number 2. Check this out. Doesn't even start at 0 or 1. This one's negative 2.98. This one's negative 2.75. This is negative 2, positive 1, and 13. There's no common difference. There's no common ratio. So now it's like, but look at, we do see a pattern here. From here to here, you add 2. From here to here, you add 2. From here to here, you add 2. And from there to there, you add 2. So maybe that could help us out. But I do not see any pattern on the bottom. I am going to graph it to see what we have. So it's kind of like a guessing game right now. So I'm not going to graph those right now. I'm going to go 0 down 2, right 2, up 1, right 4, up 13. So that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, way up there. So now that doesn't really help me. So I'm going to do this one. So left 2, down about 3, and left 4, down about 3. So look at this thing. Doesn't it look like exponential growth to you? But we know it's not, we know it doesn't look like the one we just did. And it's like, well, what are we doing then? Well, the only thing, we know it's exponential growth. We have a feeling about that. And the only thing we know about 2, so let's do that. So if you put in a 0, you get a 1. Look, we can need negative 2. So what if we manipulate it? What if we write minus 3? Get 2 to the 0 minus 3 is 1 minus 3 or negative 2. That worked. But will it work for the other ones? I don't know. So 2 to the 2 minus 3 is 4 minus 3, which is 1. That worked. Let's do one more. 2 to the 4 minus 3 is 16 minus 3, which is 13. So that's our equation. So the graph, it looked exponential. We did not have anything to go by except for that 2. So we didn't know if this was 2 to the x, 3 to the x, 4 to the x. We don't know. So all we had to go by was a 2. So when I wrote it 2 to the x, it didn't work. So I forced it to work for 0, and it just so happened when I forced it to work for 0, it worked for the others. And like I said, to me, these are challenging. There's only 2 of them. I did them for you. It's problems 1 and 2 on the practice AB. All right, I am done today. Do you guys want to ask me any questions about anything?
Where did you get the -3 from?
I just guessed.
Oh,
Because
okay.
when I put in 0, 2 to the 0 is 1. And I don't want a 1, I want a -2.
Okay, I get it.
So if I subtract 3, 2 to the 0 is 1 minus 3 is -2. That's what I want in my table. So we feel pretty good about this, but this next part, you're going to have to guess using one of those points. So you're trying to get these, you're trying to input an X and output a Y. And it's like a puzzle. It has to work for all the terms. So in other words, if you put in a +4, you better get a 13 out. If you put in a -4, you better get -2.98 out. And this is what does it. So yeah, it's difficult. It's difficult to explain. It's difficult. So my recommendation is do a graph and try to guess what type of graph it is and see if there's any patterns in the table and go from there.
So you guessed to find 3, right?
Not really. When I put in 2 to the x, 2 to the 0 is 1, and I don't want 1, I want a -2. So what do I have to do to this to make it a -2? 1 minus what is -2?
All right, I see.
2 to the 0 minus 3 is -2, right? So then after I guessed, I tried these other ones out to see if it's going to work. I'm trying to write something that's going to work for all of them. Okay, now I have not posted the assignment yet. I do have it done. But hopefully done with this thing. I will post the book, but you just know we're doing the book work and I'm doing practice AB and the evaluate online for 13-1. All right, any other questions? All right, you guys, I hope you have a good day. All right, have a good day. And I will see you on Friday. So I'll see you on Friday.
Bye, Miss Birch. Have a good
Bye,
day.
guys. Have a good day.
Bye, Ms. Birch.
Bye, guys. Have a good day. Have a good day.